This is Mr. Beck Does Your Homework. This is AP Physics, Homework 5.3, question number 6. A satellite moves in a circular orbit around the Earth at a speed of 5.2 kilometers per second. So my speed is going to be 5.2 kilometers is times 10 to the 3. It's thousands of meters per second. Determine the satellite's altitude above the surface of the Earth. Assume the Earth is a homogeneous sphere of radius 6370 kilometers. So I know that the radius of the Earth is 6370, let's see, kilometers. That's another 3 zeros. Okay? And mass of 5.98 times 10 to the 24th kilograms. The mass of the Earth, 5.98 times 10 to the 24th kilograms. And the G is that. Answering units of kilometers, so that's another thing I'm going to have to worry about. Now this radius of the Earth, I'm going to hold that out for a second, because what I've got is I've got the Earth with a certain radius, and this satellite is orbiting at some speed above the Earth. So the R that I'm going to use in my equation is going to be this R. That's really the radius. That's the radius of the orbit of the satellite. That's what I'm interested in. And then I'm going to subtract the radius of the Earth from that to get the height above the Earth, because this is asking for the height above the Earth, altitude above the Earth. So now, what does this all tell me? I got a velocity, I've got the mass. Well, what I know here is on that satellite, I have only one force, and that is the force of gravity. So I know that the force of universal gravity is going to be the centripetal force that brings it around in orbit. The universal force of gravity is G, mass of the Earth, times the mass of the satellite, divided by the orbital radius of the satellite squared. And I know that the centripetal force is going to be the mass of the satellite times the speed of the satellite squared, mv squared, over r. Well, the mass of the satellite will cancel out. This radius will cancel out one of those. So I know that the velocity squared is going to be g, mass of the Earth, over the radius. I'm looking for the radius of that satellite's orbit. So I can say that r equals, rearrange this, pull the r up there and the v squared down there. It's going to be universal gravitational constant, mass of the Earth, divided by the velocity squared. So there's my velocity. Here's my mass of the Earth. There's g over here. That will give me the radius of the satellite's orbit. That's not what it asks for. Sorry, 1T E L L I T E. Okay, so that's the radius of the satellite's orbit, but that's this whole thing. Okay, I've got to subtract from that the radius of the Earth in order to get the height above the Earth. So I'm going to take that r of the satellite, r sat, minus r Earth, is going to equal the answer that I'm looking for. And don't forget, it says answer in kilometers, so we'll take whatever that is and divide it by 1,000 to get kilometers.